Good morning and welcome to the Introduction to ION-E webinar presented by Hanu Kalomaki, Manager of Technical Training and Services at CommScope. Today's webinar is being recorded. We will have a Q&A session at the end of the presentation, so if you have any questions, please type them into the chat feature located at the bottom left of your screen. Hanu, I will hand it over to you to begin the presentation.
Thank you, Tanya, and good morning, everybody. Again, as Tanya said, my name is Hanu Kalomaki. I am the Manager of Technical Training and Services here at the CommScope DCCS, or the in-building division of CommScope. I'd like to welcome you to the ION-E Introduction webinar, and I would like to start by imagining the ideal enterprise DAS. I have a couple of what-if bullets here, or what-if wishes. What if the enterprise DAS would mirror the IT data network, which would make it easy for the IT personnel to understand and picture the enterprise DAS? What if it would be easy to install and commission? What if it would provide ultimate flexibility in traffic steering and expansion, both in a larger geographic area and to more capacity? And also, what if the DAS would be guaranteed to be free of PIM forever? Those were the wishes that we had in mind when we designed the platform called ION-E. And that is a CommScope's enterprise DAS platform. It is designed specifically for enterprise market requirements. We follow the IT data cabling rules, media and installation practices. The same rules that apply to data cabling also apply to ION-E installation, which makes it very easy for IT personnel to plan and have installed. It provides ultimate flexibility in expansion and traffic steering compared to any of our legacy platform DAS. We can expand it to up to 4,000 UAPs or remote units, and I will explain to you how that is done. And because we use media that is based on the IT architecture, there is no PIM concerns or PIM testing required, which will, first of all, make the performance a lot more reliable and the installation a lot more cheaper than with the traditional legacy DAS products. The key attributes of ION-E are simplicity, scalability, and flexibility, and I will address all those in the next couple of slides. ION-E is a very simple platform. The design, all our products are broadband products. They cover the entire frequency band from 380 to 2700 megahertz. So they are globally compatible for any commercial or public safety standards that are used today or in the future in that frequency range. The RF planning is similar to Wi-Fi planning, and as I mentioned earlier, the cabling design and installation rules are the same that they are with structured cabling. Installation is easy because we can use the pool of data cable installers. And again, since we don't have any coaxial cable in the RF path, we cannot create PIM in the ION-E system. The optical connectors, the LC connectors, they can be field terminated, which again makes for flexible and easy installation practices. Commissioning is done so that it's automatic signal detection. We detect which signals are received by the ION-E system, also which hardware is part of the ION-E system. And all this can be done remotely. And I will again address those a little bit later. Now, traffic steering is one of the key features of ION-E. Everything is software controlled, so we do not have any physical splitters or combiners in the ION-E. We can take any signal that we detect at the input of the ION-E system, and we can send it to any UAP, which is the remote unit that we use in the ION-E system. And we can support the all licensed spectrum in North America on a single cable. So we can support 320 megahertz of spectrum on a single cable. We can support any technology within the 380 to 2700 megahertz, and adding new bands is typically just a software update. So it's scalable also in expanding new services and new bands and technologies in that. Everything is based on structured cable, so it's Cat6a based architecture. As needed, we can use fiber to extend the distance or capacity of the system, and I will cover that in a moment. And we can also integrate the system with Wi-Fi or other IP appliances such as IP cameras easily. And again, I will cover that as well. We can easily grow the system from 16 UAPs to over 4,000 UAPs. And this is all done without any physical splitting or combining. So the link budget would be very similar for a small system than a large system. It's all done by routing the signal or steering the traffic to the desired areas of the building or the desired zones. We can daisy chain up to 2 UAPs or our remote units. And we can also serve multiple buildings in a campus quite easily by using the fiber connection between 2 subracks. The key values. Again, we are frequency agile. Anything between 380 to 2700 megahertz is supported by ION-E. We support multiple operators, multiple technologies, multiple modulations at the same time. And the infrastructure we use is standard IT infrastructure. It's a Cat6a, and then either single mode or multi-mode fiber depending on the application or availability of the fiber. Hardware is universal, so it's globally compatible. We only have about a dozen common SKUs that are used anywhere in the world. Subracks are interchangeable. They can be configured as a CAN or a TEN, and I will cover those in the next couple of slides. And again, performance covers everything from 380 to 2700 megahertz. These are the primary system components of an ION-E system. We have the central area node or CAN. This is where the base station is connected. This is where we do the system control. This CAN can support 16 UAPs. If you want to expand the system to higher number of UAPs, more than 16, or the distance from the CAN to any of the UAPs would be more than 100 meters, which is the Ethernet standard, then you can add a transport expansion node, or TEN, to extend the distribution of that, either to add more UAPs or to extend the distance between the CAN and the UAPs beyond 100 meters. Connection between CAN and the CAN and the TEN is done with fiber, either single mode or multi-mode fiber, and the connection from either CAN to the UAPs or from the TEN to the UAPs is over Cat6a cable. Both these subracks provide power or remote powering for the UAPs. They are powered over the Cat6a cable and is based on the Gigabit Ethernet transport standard. And the UAP, the Universal Access Point, is the remote unit we use with ION-E. We support all frequencies and all technologies. It is powered PoE or Power over Ethernet. And then we have wireless Wi-Fi applications, Wi-Fi add-on. We can connect Wi-Fi access point to the auxiliary port of a UAP. And I will show that again, how that is done. So this is a typical installation of an ION-E system. Everything starts with a central area node which receives the signals from the base station. We can connect UAPs directly to the central area node here. But if we want to expand to beyond 16 UAPs or beyond 100 meters of distance of Cat6a cable distance, we can use fiber optic cable, either single mode or multi-mode, between a CAN and a TEN. And then again, each TEN can support up to 16 UAPs, and then we can data chain many of those together. And I will show how the scalability of this works. And here we see a couple of examples. Here we have 2 UAPs cascaded using the one Cat6a cable. That is possible. We can also add IP devices such as Wi-Fi access point or IP camera to the auxiliary port of the UAP. So we have a CAN, TEN, and the UAPs, and the connection between CAN and TEN is fiber optic cable. On a high level, we have eNode B, or the LTE base station, connecting to a component called ePOI, or Enhanced Point of Interface, which receives the signal and then has in the front QMA ports. There's a DIN connector in the back and a QMA connector in the front, which then connects to our RF donor card, which is part of our CAN or central area node. And After that, we convert the signals to the software domain and do all the routing then in the software domain. From the CAN, we can feed up to 16 UAPs using the Cat6a and Ethernet ports, Cat6a cable and Ethernet ports in the front of the on the bottom left-hand corner of the CAN. And if we want to, like I said earlier, if we want to expand beyond 16 UAPs, or if the distance from the CAN to any of the UAPs is over 100 meters, we need to expand that using a 10, which is a transport expansion node, which would be here. So we have eNode B connected to the ePOI, signals coming from the ePOI to the RF donor card, and then we are supporting up to 16 UAPs directly from the CAN, and then we have multimode or single mode fiber connecting the CAN to 10s, and each one of the 10s can support 16 UAPs. Let's look at the scalability of the system. We can have 8 CANs in the system. Each one of them can have 32 10s. So these are, in this configuration, what we have here, we have the optical cards here which provide the link between the CAN and the 10. If we populate all 8 slots, including these with the optical cards, optical modules, then we will have 8 times 4 or 32 links. That's how we can support 32 10s from one CAN. And each one of the 10s would then support 16 UAPs. So 8 times 32 times 16 would be over 4,000 UAPs in a single system with no splitting or combining losses. So that is pretty amazing compared to any other legacy platform DAS solutions. If we only have one CAN in the system, no 10s at all, we can support, if we have one CAN, we can have 32 10s, and then each one of them can have 16 UAPs. So that would be 32 times 16, which would be 512 UAPs. So a very large system, even with a single CAN and multiple 10s. The UAP, or Universal Access Point, we only have one model available that supports the entire spectrum from 380 to 2700 megahertz. The antennas are built into the UAP. It can be mounted on the wall or in the ceiling. And again, it is powered, and the data is provided to the UAP using Cat6a cable. ePOI is our enhanced point of interface. In the back, we have the DIN connectors. We attenuate the high power signals by 30 dB and then feed the RF donor cards. We can fit 8 modules in one sub-rack, and each one of them has 4 inputs. So we could do 2-band MIMO or 4 separate bands or any 4 inputs per ePOI. So the space savings with this compared to any traditional point of interface solutions, they are tremendous. And again, everything is broadband from 380 to 2700 megahertz. The WCS subracks, or wireless communication switch subracks, can either be configured as a CAN, again that's a central access node, or a 10, which is a transport expansion node. This would be a CAN where the RF signals are coming from the base station, received at the RF donor card, and then we manage the distribution of those signals to the UAPs or to the 10s and to their UAPs in software domain. Any subrack can be configured as a CAN or a 10. This is a software selection on the GUI. So CAN is the base station interface, and that's where we manage the central signal distribution. We send any of the incoming signals to any of the UAPs. And the 10 is an intelligent switch and signal consolidation. We have a fiber optic cable connecting CAN to the 10, and then 10 will send the selected signals to the chosen UAPs. And they are available in 2 high-tuned and 4 high-tuned subracks. We have 5 cards that are universal globally. So if you look at any of the subracks, all the downlink input is always on the right side of the subrack. which means that for the CAN, this would be the RF input. So downlink input would be an RF domain for the CAN. And for the 10, we have the optical link coming from the CAN left side downlink output going to the 10 right side downlink input. So you can tell from the location of the optical cards whether the sub-rack is configured as a CAN when it's on the left-hand side or a 10 when it's on the right-hand side. And only the bottom quadrant, bottom 16 slots here support power over Ethernet, so we cannot combine or add up to 8 of the CAT cards or copper transport cards on this side. Is limited to 4. 4 times 4 is 16 UAPs. But on the other hand, we can have 8 optical cards on the left side of the CAN, which then will support 32 10s at the same time. So all modules are wideband. So ePOI provides a 30 dB fixed attenuation for 4 paths. We have DIN connectors in the back, QMA in the front, and then the QMA connection from the front panel of the ePOI is then fed to the RF donor cards QMA inputs. So we can have 4 duplex or simplex connections. If we have simplex connections, we need to pair uplink and downlink ports together, which is an easy software command. These are the universal cards. We have 5 cards available for ION-E. First, we have the RF donor card, which is the interface to the signal source. That's where we receive the signal and then convert that to software domain, which is the key to the ION-E flexibility. CAT card is the one that provides the interface to the UAPs, provides both the data and the power over Ethernet to the UAPs. Optical card is the interface between CAN and the 10, and the optical card modules, SFP Plus modules, can be either single mode or multi-mode modules. They're off-the-shelf modules that can be used with the OPT or optical card. And the system user interface, that is where you do the system commissioning either locally or remotely. So we have the local connection and 2 LAN ports available for the connection. And then we have the AUT or auxiliary transport card, which provides access to the 1G bypass, which would be, for example, Wi-Fi access point or support of any IP device over the ION-E system by using the auxiliary port of the UAP. ION-E is powered by a power supply, sub-rack, and modules. We will have 12-volt DC power provided to the ION-E sub-rack and the 57-volt DC provided to the UAPs. It's all co-located with either CAN or a 10 because that's where the UAPs are powered from the CAN and the 10, and the power is provided by the power supply sub-rack. Planning and installation follows the Wi-Fi planning and installation practices. The installation is based on a structured cabling infrastructure. We have a Cat6a cable and multi-mode and single-mode fibers as needed. But we always will have a Cat6a cable. The SFP Plus modules are off the shelf, and the cable routing for Ethernet cable or Cat6a cable is a lot easier than with half-an-inch coaxial cable. With twisted pair, we must have Cat6a. We cannot allow Cat5e or Cat6 in an ION-E installation. It is based on Cat6a architecture. The maximum length follows the Ethernet standard. Between 10 and the UAP or the CAN and the UAP is 100 meters. If we want to extend the distance over 100 meters or support more than 16 UAPs, we will need to use an optical fiber between the CAN and the 10, and they are just a standard single mode or multi-mode cables, and using field terminated LC connectors, just like in normal structured cable installation practices. A couple of words about the commissioning and maintenance of an ION-E system. We detect the hardware automatically and can configure that with extreme flexibility using the software or the GUI on that. It is a very simple maintenance, and that provides for intelligent monitoring. And we have service level alarming provided for easy fault location, makes it easy for non-RF personnel to monitor the performance of the ION-E installation. We have automatic hardware detection. As soon as a component is plugged in, it is automatically detected by the ION-E system, and that applies to all subracks, cards, and UAPs. They're automatically detected and displayed on the GUI, and then you can select what you want to configure right on the GUI. The RF donor card measures the RF signals that it receives. We get the information directly from the RF source, which is typically a base station. We can tell who is the operator, what is the modulation, what is the reference power, signal power level, and then we set the output power per channel automatically. So this is very different from standard or legacy DAS platforms where you have to work on gain and attenuation. This sets the output power per channel automatically based on the reference power or the pilot signals that it receives. And we can identify every operator, we can identify their technology and sector, and then send that to the desired UAPs. Now let's talk about how we do that. We have a cable connection, whether it is Cat6a or fiber. As part of the ION-E, we can support up to 320 megahertz wireless spectrum over each cable. And this is the active spectrum, so this will support the entire commercial spectrum available in North America. So we can support the entire commercial spectrum. So when we detect the signals, we detect certain channels or bandwidths that are being transported, but we only transport the active spectrum. So we combine the spectrum into a window and transport that over the media. And we have a full control over each channel. We can turn channels on and off, control the power, and we can distribute the channels to any UAP with extreme flexibility. So any signal can go to any UAP. We detect the signals, we create signal sets, and then those signal sets can be sent via software or the software command to any UAPs or any TENs. Let me give you an example of how that is done. If we have a building that has 3 zones, these 3 zones would be the same for any operator that is joining this DAS, this enterprise DAS, and each zone has a certain number of UAPs assigned for that. So this is common information for all the operators. Now we have 3 operators, operators A, B, and C. Operator A, they have different number of sectors. So zone 1, 2, and 3. We have operator C has 3 different sectors, whereas operator A only has 1 sector across those 3 zones. So we can send any signals to any of the UAPs. So in this case, operator A sector, we would send the same signal set for the operator A to all the UAPs, whereas we can have 3 different sectors going to 3 different zones for the operator C. The UAP can have only 1 assigned signal set. So we create signal set for zone 3, zone 2, and zone 1. And the signals that comprise the signal sets are different based on the operator. So this would be the way we do that. We, for example, create a new signal set called zone 1 and then select which channels go to that signal set. Then we create zone 2 and zone 3. So we can have the same sectors, same signals in multiple signal sets, but only 1 signal set can go to any of the UAPs. You can either send the zone 1, zone 2, zone 3 signal sets. If you send them directly to a 10, then it will automatically be distributed to all the UAPs that are connected to that 10. This is how you would probably do that in most cases where you have a zone driven by a 10. So you just zone 1 would go to the 10.3 or whatever 10 is driving that zone. let's talk about the UAP. UAP is a universal access point. It is powered by enhanced power over Ethernet. We have two independent PoE circuits within the Cat6a cable. So we can either support two UAPs or another IP device connected to the auxiliary port of the UAP. So this provides us a couple of options. We can either have two UAPs used for MIMO, Path 1 and Path 2, and they are powered and supported by the same Cat6a cable. Or we can have second unit used for additional frequency bands. We have 320 megahertz of spectrum available at the UAP, and that applies to both uplink and downlink. So we have 320 megahertz of uplink and 320 megahertz of downlink, so which supports the active spectrum in North America. The other option for the auxiliary port is instead of using a second UAP, we can use a Wi-Fi access point or an IP camera based on the 1G or 1 gigabit standard. So we can power those, and we can have Wi-Fi supported over ION-E very, very easily. As long as we have a Cat6a cable, and again we have two circuits within the Cat6a cable to power either two UAPs or one UAP and an IP device. I'd like to summarize this presentation. ION-E, we feel, is an ideal platform for enterprise DAS applications. It's based on the IT data media, Cat6a and optical fiber, and that can be either single mode or multi-mode. It is very simple in design and deployment. We don't have to actually do link budgets, and we don't have to set the gain of the system. The system sets the output power of the UAPs based on the standard and the modulation that it receives. And also the structured cable installation rules and practices apply to ION-E, which makes the installation pool a lot larger and also eliminates the need for PIM testing as part of the installation. So not only PIM testing, but the PIM concerns as far as the long-term system performance is concerned, they don't exist. So this concludes my presentation. I will mute my line for a minute or so. I will review the questions that we have received during the presentation, and then I will unmute my line and read some of the questions and the answers to all of you. So thank you. Just hold on just a second.
Just a reminder, at this time, if you have any questions you would like to ask, please enter them into the chat feature located at the bottom left corner of your screen.
Hello again. This is Hannu Kellomäki. I've reviewed some of the questions here. And one question from Reese Fernandez was, is the ePOI rack optional, or must it be used for the system? The ePOI, the primary function of the ePOI is to reduce the high input power from an LTE eNode B. So that is typically used just to protect the RF donor card input. But if you have lower power base stations, for example, maybe 27 dBm or lower base stations, you can connect them directly to the RF donor card. ePOI is recommended just to protect the input of the system. Also was a question there about the power of the UAP, output power of the UAP. It is 18 dBm per band, but we can have 2 bands in the lower spectrum and 2 bands in the higher spectrum. So we would have, for example, for 700 and 850, we would have 18 dBm per band, which would be then 21 dBm. And for higher bands, we would also have 2 times 18 dBm, so that would be 21 dBm. And then the composite total power of the UAP would then be 24 dBm. And another question came, are the modules hot swappable? And the answer is yes. That is part of the ION-E automatic detection. Any modules are hot swappable, and the software automatically, or the system will automatically detect the modules that are inserted in the system. And you can also disable any of the active cards, and all the cards are active on an ION-E system. You can disable them in the software, and then they will show us at the grayed out. They still show that they are in the system, but they're not active. Another question was, what is the length limit for the UAP cascading? Again, it is the same 100 meters from the either CAN or the 10 to the second UAP. That cannot be more than 100 meters. And that's just based on the Ethernet standard. If you have an installation where you would need a longer distance, then you need to consider the 10 and an optical connection between the CAN and the 10. In a typical office environment, that is very easy to gauge, because if you have an Ethernet port in the office, you know that that Ethernet port is not more than 100 meters from a switch or router. So that can be determined that yes, it would be possible to place a UAP near that. Especially the UAP would be in the ceiling, so you don't have the vertical drop going back to the Ethernet port. One of the questions was, I think it was Rich Jimenez, was do we support 5.8 gigahertz? And actually we do, because the 5.8 gigahertz Wi-Fi would be supported through the 1 gigabit bypass or the transport. So we can have 5.8 gigahertz transport over ION-E. The UAP itself would not support the 5.8 gigahertz, but the access point, the Wi-Fi access point that is connected to the UAP, can support the 5.8 gigahertz Wi-Fi. So that is perfectly available today already. And I think that's okay. One question came: how far can the CAN be from the 10 over single mode fiber? This is again based on the structured cable designs, and that distance would be 10 kilometers. So it's a long distance. Can be used between buildings inside a campus, or between buildings in a campus. Easily can be supported over single mode fiber. And the multi-mode fiber were limited to between 330 and 500 meters, depending on the specifications of that multi-mode fiber. I think this completes all the questions that we've seen here. We will review. If you still have any questions, you can send those, and we will log those and then address those directly. But Tanya, this concludes my portion of the presentation. Do you want to take over?
Okay. Thank you everyone for joining today's webinar. This is a reminder, keep your eyes open for an email that will go out tomorrow with a replay link of today's presentation. Have a great day.